Hello, and welcome to our LinkedIn Live session. We are going to talk a little bit about how to protect digital transactions with API and web application security. But I think today we're going to focus on why a different approach is needed than purely transactional based uh, protection and detection. Gary, could you tell us what transactional based detection is?
Hello again, everyone. Yeah, to take your question about transactional based security. When we're looking at something bad happening, or as our colleague likes to say it from last time, there is someone who is throwing the snowball, and there is the snowball that is going to hit you. So the transaction is the snowball, and then entity is, I guess you didn't ask about entity, but that's the snowball thrower. So yeah, transaction, we're focused on the thing that is bad.
Right. So a transaction would be good for detecting a known bad, like an
Mhm,
OWASP level attack or something like that, where it's understood that this is a
mhm.
bad transaction. But
Yeah.
perhaps it can't detect other things that are maybe good transactions that are bad. Or could you explain that to us a little bit?
Yeah. So when it comes to transaction-based security, if we're still focused on transaction-based security, essentially when you're looking into the transactions outside of if it's known it's bad, there are a lot of other factors that you can take in to build like what is considered a bad transaction. It's not necessarily just by a set of rules. So an example I could give is if I'm looking into, I'll use an example with students and teachers. Essentially, let's say a teacher, their goal is to teach class, and a student, technically, what is a legitimate transaction is to ask questions if you don't understand. But you could have malicious intentions with these transactions. As an example, if let's say I'm a student and the teacher in my class, I know my teacher really likes, let's say, his dog, then what I could do as a way to stall class, and let's say we have a test coming up or we have material we need to cover, is I can be really nice to the teacher and go, "Hey, how's your day going? Can you tell us about your dog's health? How's that been coming along? I'm thinking about adopting a dog." These are completely unrelated to class, but the questions themselves can seem they aren't malicious. Therefore, we end up wasting time, and that's my ultimate goal. So, in addition to entity, which we'll talk about later, transactions can also have nefarious intentions without looking like it.
Okay, I get that. So tell us how entity-based tracking would help solve the problem of legitimate requests that um, actually do bad things.
Mhm. Where entity-based transaction comes in, at least I would say from my understanding of it, is that you're adding in an extra factor that you can consider. Ultimately, with all this stuff that people say about AI and machine learning, we like to say it's like complex math because you're essentially building like a regression model and you're adding an extra variable that you are considering. So in the example for what you're asking, right? How does that help with it? Well, now in addition to looking at let's go back to the student versus teacher. In addition to looking at the questions that the students are asking the teachers, you can also kind of build out profiles for based on behavior. What kind of student is this? Is this actually a question made to ask to, you know, further a class? Or is this a student potentially acting to do delays or to throw the teacher off?
So it's a little bit of like profiling
Mhm.
and adding of context based on
Yeah.
what I learn from profile and type of request. Oh,
Yeah.
that's pretty neat. How do we apply that to then WAF security, right? How do I stop attacks that are outside of the normal OWASP that are maybe 0 day or that are just complexly strange or new?
Yeah, that's a great question. Like you mentioned earlier, if the transaction is something that has been recognized, like let's say cross-site scripting, right? That is something that has been recognized by OWASP. We probably have methods of trying to stop it. But where entity comes in is because if they're using a new method that hasn't been tracked before, what's your next best thing that you could do? Well, then you try to track based off the behavior of an entity. You have a profile, right? For a profile, essentially what we're saying is if any of you guys have watched Criminal Minds before, there is the BAU, Behavior Analysis Unit. Pretty much what they do is there is a profile for certain types of, not necessarily only serial killers, but let's just say people who are offenders, right?
Okay.
And usually in these episodes, they'll say, okay, we are looking for a serial killer who has a godlike complex. And usually they have a description of their age, most likely what they have been doing in the past 10 years, things like that. So now let's take that into the security world. Well, they aren't necessarily humans, but these entities are being operated by humans. And there's a behavior that these entities have. If this entity is exhibiting behavior that follows what we noted as, oh, this is kind of like toxic behavior, then we can make a note of it. And that way, even if the transaction is something we've never seen before, we still have a chance of stopping it because we noticed, hey, this entity isn't behaving right. Let's look into it.
Is that our feature we call HackerMind?
Oh, for specifically for ThreatX by A10, that is what we call HackerMind. It's essentially the decision-making engine. And it's very complex how it goes into it. We're trying to simplify it. But essentially, you have all this context that we talked about. You gather all this information. You have this profile. Well, just because you have a profile, we don't block it completely, right? We may have prejudice towards this type of profile, but similar to how we try not to be like, cops try not to be racist in real life for security purposes. Same idea. We're going to say this profile has a elevated risk score, so let's beware of it, and we'll have like gradual mitigation steps.
So how does that work around API security?
So API security, this one is when it comes to entity versus transaction, why you would need both, right? I would say it's a step more dangerous than WAF because for an application, because when it comes to application, let's take cross-site scripting as an example. The way that I had learned originally, how one of the ways that cross-site scripting can happen is, I know most people have Facebook. If you go to Facebook and you see a post, right, like there's a picture and someone writes a comment there, you have an option to write in a comment and you click reply. Well, most of us are going to say, oh, hey, congratulations, or wow, that looks amazing, right? But there is a way where you can write in a comment where it looks like script. Like you start with the less than, and then you write script colon slash slash, and then you can literally write in code. And depending on how this web page is formatted, the back end engine of it could interpret your comment as code rather than a comment. So, but this is a little different from APIs because when it comes to WAF, you're looking at a web page. Therefore, there's a limitation to how backdoor it can get into the actual internal systems of, for example, Facebook. But APIs, it becomes more dangerous because APIs, or application programming interfaces, they allow machines to talk to each other. You're actually getting into the back end. You're like looking into the engine of the car. So if someone is able to execute an attack successfully on an API, they could get access to, I don't even know what. So then to bring this back to the entity versus the transaction-based tracking, why you have to do both. It's the same idea. For APIs, there's so many transactions happening and APIs have so many privileges because of what they should be doing, that a lot of transactions are going to look legitimate, but they actually have malicious intentions. Therefore, if you attack an entity-based tracking, not only are you're able to get this extra factor to consider, and it's that way, even if things happen, you have a better chance of stopping them and detecting them.
Let's switch to what I find is a very difficult type of attack to deal with, and that's like a slow LoRa's, right, or a layer 7 DDoS. It's kind of a new thing, more or less, in the industry, or I should say, it's become a bigger thing. It's always been there, but it's become quite the thing these days because most DDoS protection is down at a different layer. It's actually blocking UDP floods or DNS attacks or volumetric style things on the wire, network layer attacks. But this happens up in the application, so it's typically not volume, right? It's typically other types of things. So how does it help us with doing this very hard task of layer 7 DDoS?
Yeah. I thought maybe we could first start with, one step before. I just want to mention the volumetric really quick. Please do correct me about this one because this one I've like looked into a little bit, but I wouldn't say I'm like an expert on this one. When it comes to layer 7 DDoS attacks, I think part of the reason why there isn't as much there, you can execute volumetric attacks there as well. But part of the reason they aren't executed as often is it because the cloud can just scale? And if it scales, it can stop the volumetric?
No, typically it's a layer 7 attacks are typically business logic attacks
Okay.
that that are more like a slow post, slow loris, where you may have a form on your
Mhm.
website that somebody fills out. Well, or it's asking for information from you, and you leak the information back to the website very slowly within the TCP timeout
Mhm.
interval. And so this
Yeah.
keeps the socket open, this balloons memory, and then I open the second one, right? All
Yeah.
of these are legitimate. I can respond slowly. There's an interval for timeout. I haven't
Mhm.
gone beyond the interval. And a typical DDoS detection device is really not configured to understand that because it's a logic problem,
Yeah.
not a volume problem, right?
Yeah.
Now, as a volume, for example, if I request your homepage 200 million times, I will eventually trip your volumetric defense.
Mhm.
But
Mhm.
but sometimes that can be a different sort of attack. So if I observe your website long enough, do enough reconnaissance, I can begin to understand which pages are harder to load. Some of
Mhm.
them may require backend SQL
Yeah.
transactions. Some may have images. Some are maybe using API calls to different places to bring together all the data that's displayed on a page. So there are hacker tools out there that will let you gauge the load of a
Mhm.
page,
Mm.
right?
A few quick things I'd like to tack on to what you're saying, because
Yeah.
that's really good information, especially about when it comes to like slow lowers type of attacks. For the business logic, that's a new type of attack that definitely entity-based tracking benefits from, or rather, I would say entity-based tracking is very strong at identifying, because when it comes to business logic, this one's scary because, like you said, you're no longer breaking into the system. Rather, you are understanding the system so well that you know where its flaws are, right? And to make a
Yes.
call back to, I like to make a call back to Avatar: The Last Airbender. It's a cartoon series that was very popular. I remember there's an episode where they're literally playing volleyball. Okay. And while playing volleyball, one of the Princess Azula, she says, that lady has a bit of a limp, and I could tell that she favors her left side. So always hit to her on that side. It's kind of like how a business logic attack works, because like you're saying, if you understand the site well, you know what parts are slower. So you just keep pushing those buttons, and then
Yes.
it becomes an attack. And it looks legit because all the transactions are legit. You followed the business logic. Then,
Yeah.
as a general thing, the other thing comment I was going to make was about slow loris in general. Yeah, there's more than one way. For DDoS type of attacks, your goal is to get downtime. And if I take it back to the student versus teachers, right? There's lots of ways you can do it. If I'm a student, I can ask the teacher thousands of questions, but the teacher's going to realize, like, hey, you're just asking thousands of questions. But a way that I can throw it off is if I'm talking to the teacher and I ask a few questions, but they're so complex that the teacher takes a long time to think about it and get back to me.
Mhm.
You're still going to achieve system downtime essentially. So those
Right.
are, I thought you brought up some really, really great points.
So how does entity-based tracking help with that? Because it's
Mhm.
almost impossible transactionally because
Yeah.
it's a legitimate transaction.
Yeah. Well, when it comes to here, one of the ways that when it comes to layer 7 DDoS, right? The way that we're able to protect against it by using entity is because, like we mentioned earlier, there's multiple factors that you can consider. There is the attackers themselves, right? And for this one, I'll go a little bit more in depth, just a bit, because I know for a lot of DDoS attacks, they are executed by general botnets, right? So let's say we notice an entity seems to be misbehaving and we elevate the risk score to a certain degree. Then, when it comes to the mitigation component, maybe we'll say, okay, block off this entity. And the reason we don't want to block it all is because we're trying to learn more, right? We want to see if this is indeed malicious. We don't want to throw a bunch of false positives at teams. So if we block one, if it's part of a botnet, then the rest of the botnet would adjust because this entity is now gone. And if you see there's a relationship that exists, that could provide insight into what's actually going on here, if it's malicious or not. So I hope that
So
kind of helps a little bit. Yeah, please
it
go ahead.
does. Yeah, I just want to clarify there. So that's sort of it's instead of summing or understanding just what an entity does, that's sort of horizontal
Mhm.
entity-based tracking, where I'm
Right.
watching a group of entities and one is bad, maybe we take it out, and then another one increases volume or some
Yep.
sort of response directly to our tar pitting something.
Yes, yes. And to add on to that, you actually brought up a really good point when you were mentioning about the horizontal part. What's important about this is when you are gathering all this information, that your information is correlated across. Ideally, you could correlate across different types of protection. What I mean by that is if you find an entity that's misbehaving and it seems to be executing an API attack, there isn't anything to say that this entity couldn't also be trying to execute, for example, an application attack, or it could be part of a layer 7 DDoS scheme. So when you collect this data and this profile it is built, it's going to be you're going to keep this profile and continue to correlate information into it across these different methods of potential executing attacks.
And so what you're saying there, Gary, is that instead of having different products or perhaps a single vendor who claims to be a platform
Mhm.
where they have cobbled together these types
Yeah.
of protections and then expect you to do the correlation in the SOC,
Yeah.
we have a single product and platform that does all of that for you and a SOC on top of that that is
Mhm.
helping you understand it. Is that correct?
Yes. I think that's a good way to phrase it because essentially there's levels to this. We talked about this in our last one, what the importance of having a single platform solution. Because yes, the worst is if you have endpoint from A, endpoint from B, endpoint from C, or sorry, security product from C, right? Then the next level is if you have security products A, B, C, but then like you said, they're cobbled together from different places. Then the level above that is if A, B, C, they actually work together as part of a cohesive system. That's going to be your best bet.
I can tell you from my experience in pen testing, that was something I always counted on. Is
Mhm.
those components didn't talk to each other. I could get blocked by the
Mm.
WAF and then switch to API, and it was a brand new conversation.
Yeah,
Everything was all new. So
yeah,
I know that to be a pretty common method, um,
yeah.
right?
Your ethical hacking days always brings in very valuable insight, I'll say.
Well, that's fantastic. So really, the news there is that security teams no longer have to manage day-to-day alerts, right? The SOC, our
Mhm.
SOC does that for them. Is that right?
Yeah, yeah. For we call us a fully managed SOC because SOC or Security Operations Center, that's what it's in reference to, in addition to what we wear on our feet. But for socks, they usually have a lot of things to worry about, right? They get all these alerts, they got to filter through them, they got to understand the alerts, understand like the risk profile of them. But we have these security experts that are coming in and they can filter through this mass of threats and try to help figure out which are the ones that actually require your attention. So having a good product is good. I used to play sports a lot, right? So people would say it's not just about, for example, I used to play badminton, and a lot of people want to buy the best badminton shoes, the best badminton rackets. Honestly, at the highest level, it doesn't really matter what equipment you have. It matters what you can do with it. So
Yeah.
similarly, if you buy the best security products out there, but if one, they don't talk to each other, two, you don't know how to squeeze the lemon completely, right? Then what's the point? At that point, you want to get someone who's an expert. And if you can equip them with the best security products, that's always a great add. But having a fully managed SOC, a tool that they're familiar with that can see across all these different dimensions, that's a very strong defensive system.
Yeah, for sure. So just to kind of wrap up here, what we're talking about is a fully integrated platform where the products are sharing what we call HackerMind. It is the back end that makes the decisions about whether something is good or bad, carries the risk score, all that sort of stuff. That system then, every component talks to the other component because they use the same back end mind.
Yeah. Yeah.
Therefore, your layer 7 DDoS is connected to your API, is connected to your WAF, is connected to your bot protection. All of these things are a single unit that we present to the web page. And then on the back end, it's managed by a group of experts, not just in the systems operation, but also in website security, API security, bot security, DDoS. They're the cream of the crop that are out there monitoring for you, and then eliminating the daily stuff that doesn't matter, giving you only the stuff that seems really fishy or important.
Mhm.
And further, don't they also help with scripting or patching and things like that?
Yeah, that you're probably talking more about the mitigation aspects of the process, right? Yeah, when it comes to the mitigation aspect of the process, there's a bunch of different steps in there. For example, there's zero-day threat mitigation, which is different from patching, because patching is more, let's say an attack was executed today. There's a new type of attack. You want to have zero-day threat mitigation in place because you want to be able to, I like to think of it as react on the fly. Then in the next coming week or weeks or days, depending on how fast you could do it, you could build out a patch. And a patch is, just like a band-aid. There's an issue, you put a patch on to protect against it. And those patches may evolve in the coming days.
Okay. Okay. So you say they're actually looking at my components that are being protected for CVEs or vulnerabilities as well.
Oh, yes. Well, if it's okay for me to just talk about ThreatX by A10 really quick, I know one really cool thing that we do is we actually check all CVEs that are relevant to our customers to figure out which ones we actually need to spend more time on and which ones they should be worried about. That way it's us going to them rather than them coming to us and going, "Hey, have you heard about this?" Right? It's important to stay proactive and stay ahead of what's happening.
So that seems to be the purpose of a true fully managed SOC
Yeah, yeah.
is they maintain the product, they deal with the product as if it was theirs.
Mhm. To transform from reactive into proactive. No longer whackable.
Right? Thus freeing up your people to do more interesting things, more relevant things, accomplish more things
Yep.
without dealing with the drudgery of dealing with a WAF.
Yeah,
Well,
absolutely.
it's been a great conversation today, Gary. I appreciate your time.
Likewise,
And
likewise. Great
maybe we'll be
question.
on here again and talk about something else about web security.
Yeah, sounds good.
All right. Thanks, everybody. Thanks for joining.
Thanks, everybody. Thanks for joining.